before moving on to the properties of glucose, let us first see another topic which is going to help us a lot called hemiacetals. Now, what are hemiacetals? So, if I take an aldehyde, which is RC double bond OH, and I take this with an alcohol. So, alcohol I'm representing as R1OH because I have to differ the two alkyl groups. So I've got an alkyl group over here, an alkyl group over here. So I'm putting an R1 here. Okay. Now, and I take these two in an acidic medium. So acidic medium is H plus. So I'm sending an H plus also here. Now, what happens is this ROH combines with this aldehyde, and what do I get is I get R C in the middle. This R is from here, okay. Now a C in the middle, and I get an OR1. Now, where is this OR1 coming from? This O is from here, and this R1 is from here. Why is that now? So if I look very clearly, let us first dot the hemiacetal. So I've got an OH, and this OH is coming from here, as you can clearly see. Also, I have got the last group, that is an H. Okay. Now, what do I observe is in this particular hemiacetal, what happens is this C is combining with this R1, and this particular R1OH, if I am to say, this alcohol is breaking up like this. So this OH, here O is an electronegative atom. So this electronegative atom goes to the less electronegative atom, that is my carbon here. Okay. And this R1 goes to O, and here I get an OR1. Okay. So this is what is happening. Why is that? Because this OH, if it goes to this O, both of them are electronegative, and we have seen that O being more electronegative will be joined with a less electronegative group. Okay, now we're done with this. So what do I get? Now this is my hemiacetal. Okay, so now what did I do? I'll just write it down. The when an aldehyde, so I'm taking an aldehyde combines with an alcohol, so it is combining with an alcohol here in acidic medium, and therefore I get this H plus. Okay, in an acidic medium, a hemiacetal is formed. Now, if you look very close to this hemiacetal, I notice that this hemiacetal has my carbon in the middle, then it is joined by an OH group here, an OR1 group here, an R group, and an H group. So I've got four groups joining this hemiacetal, and therefore I can just write that hemiacetals, what is the characteristic property? So I deduce the characteristic property from all this, and what do I get? That it will have characteristic property. So if I tell you to find me a hemiacetal, you have to see that it will have one OH group, one OR group. That is my, what is this? This is nothing but ether group. Okay. Then I'll have one R group, and the rest is hydrogen. So it will have for sure an alcohol, an ether, and an alkyl group. This is the alcoholic group, this is the ether group, this is the alkyl group. So it has to have all of this. You can say one hydrogen also. I just write here one hydrogen. Okay. So now this is what is a hemiacetal. Now, hemiacetals have one more property which is to be remembered by us, which is that hemiacetals, so I'll write down here, I can just say that hemiacetals, what do? They can show they can show Tollens reagent test. So they are giving me Tollens reagent test and Spelling solution test. Okay, so these tests, both of them are given by hemiacetals. Also, to keep a point in mind, whenever, since we are dealing with hemiacetals which are showing which can reduce both the Tollens reagent and the Fellings solution, I can get you a next category which we can just look through is reducing sugar. Now, what are reducing sugars? So you just have to remember that all those carbohydrates, what are reducing sugar? All those, we're talking about carbohydrates and what else? So all those carbohydrates which reduce, which reduce Fehling solution and Tollens reagent are called, so they are called as reducing sugar. Just to keep a point in mind, since we are dealing with hemiacetals, which are showing both the Tollens reagent test and the Fehling solution test. So I get a new category. It is called reducing sugar. And in reducing sugar, I have those carbohydrates which can reduce both the Fehling solution and the Tollens reagent. So if I want to see an example, I can write that all monosaccharides, okay, monosaccharides, whether aldose or ketos, are reducing sugar. So all monosaccharides, whether they have an al aldehyde group or a ketone group, so I can say all monosaccharides are reducing sugar. Okay, so this is a category of sugars called reducing sugars. And the other one are non-reducing sugars, of course. So the carbohydrates can actually be classified, if I want to say that all the carbohydrates that I will have within this chapter, I can classify them into two categories, namely the reducing and the non-reducing sugar. The reducing ones will be the ones which will give me both the tolerance test and the Fehling solution test, and I will have the non-reducing sugars which will give me none of them. So I've got non-reducing sugars. Okay, so this is a category of carbohydrates, reducing and non-reducing sugar. And what we did was we said that hemiacetals can show both of them. So hemiacetals will be reducing. Okay, so we just learned that hemiacetals consisting of an OH group, an OR group, an alkyl group, and an H.